Hi and welcome to this tutorial on ion formation. So in the previous tutorial we learnt about writing balance equations for reactions and performing calculations with masses, volumes of gases, percentage yield and percentage atom economy. So moving on to a slightly different topic, and we're going to be looking at ionic formation. So we're going to have a look at formation of ions and compound ions too. So I'm sure you know quite a lot of this information already, but it's really important that you've got a very, very solid foundation for this sort of content as you move into the A-level syllabus. So we've talked a little bit before about the transfer of electrons from, for example, if I've got sodium chloride here, I've got my sodium, it's got one electron, it's outer shell, it's in group 1, and it's going to transfer it over to chlorine. So they're both happy. We've got a full outer shell underneath of the sodium that we're not showing here, and then the chloride ion's now got its full outer shell of 8 electrons. And because sodium has lost a negative electron, it becomes a positively charged, a cation. And because chlorine has gained a negative electron, it is now a 1- or just a negatively charged anion. And of course, I'm not showing the inner shells of sodium here. Ions are formed from atoms when electrons are transferred, like in the example we just looked at. And of course, a negative ion or an anion is formed when an atom gains electrons, and a cation or a positive ion is formed when an atom loses electrons. And atoms are going to gain or lose electrons in order to get a full outer shell, just like the inert noble gases. So this makes the atom stable and unreactive, or this makes the ions now, obviously in those cases they're going to be ions, stable and unreactive. It's really important that we use the correct term. If we're talking about ions, we have to say ions. If we're talking about atoms, we have to say atoms. Sounds simple, but a lot of people get caught out on that with their exam technique. So when an ion is formed from a single atom, it means an electron is transferred between only one type of atom. So sodium is an ion formed from a single sodium atom. It's formed when a sodium atom, of course, loses its outermost electron. And we've got the periodic table here, and it's going to help you to visualize the changes of the ions formed by specific elements. So it depends on which group they're in. So all of our group 1s are going to form 1+ cations, group 2 are going to form 2+ cations, and group 6 are going to form 2- anions and 1- anions for group 7. Okay, because group 1's got one electron in its outer shell, 2, 6 and 7, you can see here. So as I just said, the group in the periodic table dictates the number of outer shell electrons. So group 1's got 1 outer shell electron, group 2's got 2, group 6 has got 6, group 7's got 7. And therefore the group in which you find the element dictates what type of ion is going to be formed. So all the elements in group 1 are going to have the same number of electrons in the outer shell, 1, so they're all going to lose it when they form ions, and we're going to bump to the shell below, which is going to be nice and full, and they are going to be a 1+ ion. And they have to gain or lose the same number of electrons to achieve a full outer shell, so each group. So we can see with beryllium here, we've got 2 electrons in the outer shell, so it's in group 2, and we have lost 2 electrons. So we can see we've lost that outer shell. I'm no longer showing it here. We've got the 2 electrons underneath. And this is a beryllium 2+ ion. And it's the same for the others. We're going down group 2 because the shell is increasing by 1 each time. And every time we lose the outermost electron, we lose that outermost shell. And we bump down to the shell below, which is now nice and full. And we're left with a 2+ cation. Transition elements, so most of those in the D block, not all of them, but most of them are transition elements. They can lose a variable number of electrons. Okay, so from their outermost shells, they can form more than one type of ion, meaning they've got different oxidation states. And that's why they're so colourful as well. There are 2 exceptions, like I said. We've got zinc and we've got silver. So zinc is only ever going to form Zn2+, and silver is always going to be Ag+. That's really useful to remember when you're looking at compounds. So those are 2 that you need to remember. And the charge of the transition metal ion that you get present in the compound will be specified in Roman numerals. So if you were told you've got copper 2 sulfate, then you know that that is copper 2+. And then the SO4 is going to be 2-, so it's just going to be CuSO4 in that case. So the Roman numerals tells you what this number is here. So polyatomic ions is going to be really important for you to know as well. Check your specification for which ones you have to know by heart and which ones you will be given, because there's slight variation between the different exam boards. So some of these you might have to learn by heart, some of them you won't. But we've got nitrate, which is going to be NO3 minus, polyatomic, many atom ion. So rather than learn these individually as nitrogen and oxygen, you learn them as a polyatomic ion, which goes around as a unit. Ammonia, one of the very few cations, polyatomic cations that we deal with. Sulfate, so I just gave an example. And carbonate, those are very often have to be memorized. And of course, hydroxide. A hydrocarbonate, very helpful also in biology. And phosphate, again, features in biology lots. I guess a lot of these do.